Hello, I'm Fumiya Kazawa. I draft talk to about the effect of anterior displacement of the femoral head due to hip external rotation on contact pressure in the labrum. Previous studies have reported labral injury at the labrochondral junction accompanied by cartilage damage. Such labrochondral lesions are thought to be caused by mechanical overload on the anterior region of the labrum due to anterior displacement of the femoral head caused by hip external rotation or abduction. However, this anterior displacement of the femoral head was not evaluated. We thought that the false profile view may be useful in evaluating anterior displacement during external rotation. The false profile view is taken from the side. This may enable evaluation of anterior displacement of the femoral head due to hip external rotation in a weight bearing. However, because the pelvis is viewed from an oblique angle, the anterior direction cannot be accurately measured on a two-dimensional image. We accurately evaluated anterior displacement using matching the false profile view with 3D CT model. Developmental dysplasia of the hip, DDH, is displaced anteriorly in false profile view. The labrum in the anterior region may have increased contact pressure. The aim of this study was to evaluate contact pressure on the labrum in the false profile view. The subjects were 30 DDH patients without arthritic changes and 10 patients with unilateral femoral head necrosis who visited Hokkaido University Hospital. The control group consisted of healthy hip joints. The model on the left is a 3D CT model. The model on the right is a 3D false profile model created by matching a 2D false profile view with a 3D CT model. In this study, we compared two models with different postures. The labrum and cartilage were manually segmented from MRI images and a 3D model was created. Loads and constraints in finite element analysis. The material properties were as follows. Bone was Kiak, cartilage was Young's modulus 1 megapascal, Poisson's ratio 0.4, density 1.3 mg per cubic millimeter. And labrum was Young's modulus 1 megapascal, Poisson's ratio 0.4, density 1.2 mg per cubic millimeter. The loading conditions were as follows. 99% of body weight was applied to the distal end of the femur. And tension of the abductor and gluteus maximus muscles was applied to the femoral head, resulting in a tension of 485 N. The constraint conditions were set as follows. The distal femur was unconstrained in the Z direction only, the pubic symphysis was unconstrained in the theta X direction only, and the sacroiliac joint was fully constrained. Under these loading conditions, the maximum contact pressure on the labrum was evaluated for each model. This figure shows the contact reaction force of the labrum in the control hip. The 3D CT model shows that there is little contact reaction force. On the other hand, in the 3D false profile model, a slight reaction force is observed in the antero-superior region of the labrum, but it can be confirmed that no high contact reaction force is observed in any position. This figure shows the contact reaction force of the labrum in the DDH. In the DDH, a clearly higher contact reaction force was observed compared to the control hip, even in the 3D CT model. In addition, the 3D false profile view shows that a higher reaction force is being applied. These contact reactions are seen in the anterior superior to anterior regions. This figure shows the calculation of contact pressure on the labrum. The vertical axis is contact pressure. The black graph is the 3D CT model, and the white graph is the 3D false profile model. In the control, the average was 1.2 plus or minus 0.4, but in the 3D false profile model this changed to 1.4 plus or minus 0.4. On the other hand, DDH showed a clearly greater change from 1.5 plus or minus 0.2 to 1.8 plus or minus 0.4. Therefore, it was clear that the maximum contact pressure on the labrum for DDH was significantly higher in the 3D false profile model. This is a previous study that measured strain on the labrum due to abduction or external rotation torque. In this study, a strain gauge was placed on the labrum of a cadaver. And the study reported that when abduction or external rotation torque was applied, a 1.6 mm anterior displacement of the femoral head was observed. The study revealed that this slight displacement caused high strain in the area from the front to the anterior superior part of the labrum. This study evaluated the maximum contact pressure of the labrum in DDH patients who had an average anterior displacement of 1.2 mm in the false profile view. 3D CT model showed that the control group had almost no contact pressure, but the DDH group had higher contact pressure than the control group. On the other hand, the 3D false profile model showed an increase in contact pressure in both groups, and the DDH group in particular showed approximately 120% higher contact pressure than the 3D CT model. At this time, it was shown that the high contact pressure was in the anterior superior to anterior region of the labrum. Therefore, in DDH patients, repeated external rotation in weight-bearing, such as turning movements, may cause labrochondral lesions due to anterior displacement of the femoral head. Conclusion: the contact pressure on the labrum was evaluated using a false profile model created by 2D-3D image matching. In DDH, there is approximately 120% contact pressure on the antero-superior labrum during external rotation under weight-bearing. Repeated turning movements in external rotation may cause labral tears in patients with DDH. Thank you for attention.